Hello, you are welcome to New Focus Approach to Mathematics Basic 7 Revised Edition. In this video, we want to look at how we can express vectors or vector component graphically. This lesson can be found in page 302. So we are introducing the concept of vectors. We've studied something about bearings. We want to look at vectors as well. When we talk of vectors, they are just physical quantities, okay? And in physical quantities, we have two types of physical quantities. We have the vector quantity and scalar quantity. And when we talk of vector quantity, it simply means any quantity that has both magnitude and direction. It has magnitude, so the distance here tells us the magnitude of this two point, and it's 3 centimeters. Sorry, 3 meters. It has also a direction. Was from the North Pole, it moved in this direction. Example of vector quantity can be force, displacement, velocity, acceleration, momentum, weight, etc., etc. Then we have what we call scalar quantity, which says a quantity that has magnitude but no direction. Example can be speed, time, distance, mass, density, temperature, volume, area, surfaces, that's area of a surface, etc., etc. All these are also scalar quantities. But we want to concentrate on vector quantities. And we say vectors have both magnitude and direction. And it can be represented in 4 different ways. Either we have it in the components like this, or we have it in the directional form, or what we normally call magnitude bearing form, okay, like this, 5 meters, 62 degrees. We can also have it in the Cartesian form like 3i plus 4j. You don't need to learn this because it's not part of your level. I'm only mentioning. Then we have another way we can also represent vector is using the the graphical means. So in this video, what we want to do is we want to learn how we can represent vectors on graphs. And for example, if I have vector A, which says 3, 4. Now 3, 4 simply means that I'm going to make movement on x-axis 3 steps and movement on y-axis 4 steps. Now, anytime you pick a vector, the top value represents your x-axis, whilst your down value represents your y-axis. If the top is negative, it means I'll move in the negative direction on the x-axis. And if the down 2 is negative, I'll move downwards on the y-axis towards the negative side. So that is how we go. So with this very question, let's see. We want to represent this vector on the graph. So 3 here tells us that from the origin, we should move 3 steps. And then 4 here means we have to go up 4 steps. So the point will be here. Then we join the point to the origin, and that will create the vector A, or in the position form, we can say OA. Then again, when we pick the B says move negative and then positive. So we move negative 2 to the x-axis, then positive 4 to the y-axis. So we get our point here. Maybe let's call that point also B. Then we join that point to the origin to create our vector OB, or vector B. Then the last one, we have C, which says negative 3, negative 4. So negative 3 on the x-axis, negative 4 on the y-axis. And they'll meet here. Let's call it vector point C. And that vector becomes vector OC, or vector C. So this is how we represent vectors on the number line. Sorry, on the Cartesian plane or graph. Now, this example tells us that we should write the following vectors in the form of AB, that is the component form. Now, what is vector AB here? Now, vector AB here tells us that we are at A and we are moving towards B. So we are at A moving towards B. How do we get there? We can get there by moving on x-axis and moving on y-axis. So if from the point A here to this point is 1 unit, then I'm going to move 1, 2, 3, 4, 5, 6, 7. 7 units, then I move upwards 1, 2. So because I move positive direction 7, I will get positive 7. And I move upwards 2, and then my vector becomes 7, 2. Then I'm to find vector BC. Vector BC. Also B towards C. Okay. B towards C. So I'm on B heading towards C. It means I have to move backwards 1, 2, 3, 4 to get to this point. Then move downwards 1, 2, 3, 4, 5, 6, 7. So here I'm going to move 4 negative on the x-axis, then downwards negative 7 on the y-axis. Again, to get the final one, AC, it means we are at A and we are heading towards C. And looking at where A is, it means we can only move on the x-axis positive. That means you move A 1, 2, 3 positive and go down 1, 2, 3, 4, 5. So I'm going to get positive 3, negative 5, and that becomes the vector. So this is how we represent vectors using diagrams. Thanks so much for watching.